Nope. In the top left. The big piece. Nope. Your side. Yep. Actually, yeah, you can turn around and do that side.
Okay.
This side's all ready.
Yeah, that's what I was.
So looks like you need a bigger screw up because somebody's broken this.
Okay, right now I'm gonna clean out what I'm gonna put the solution in, which isn't the graduated cylinder. This is what. So I have to clean both of these.
Yes. Yeah. Each person. Yeah. What up?
Okay, I'm just wrapping it in the.
I said, Ann. Is everybody okay with that?
In the
What do you
paper.
This
is how he did it. So this is how I'm gonna do it.
I've not seen that many.
I think you just go like this. That's what he was doing yesterday. So if anyone's wrong, correct me, please. Okay, this is clean and dry. Now I'm gonna do this one.
So for our data, we're gonna need to find. I'm just saying this because there's a section for data. We're gonna need to write down the mass of the solute, the mass of the solution,
Mhm.
the moles of solute, the kilograms of solvent. So we just need we just need separately the solute, the solvent, and the solution.
Yeah.
Like everything together.
And that'll all be in grams, so we're gonna have to like convert
Yeah,
that.
and we need liters because wait, you can convert grams to liters though.
Yeah.
Yeah, don't forget you gotta weigh the empty cylinder and the empty beaker.
Yeah.
Yeah, we know.
I'm gonna get.
We're
Well, I have
just
to weigh
trying to figure out what
this.
specifically we needed.
I have to weigh this. I'm gonna weigh this second after I get the solution. Okay.
Yes.
Okay.
Do I just grab any solution? A, B, C, or D?
What?
Do I just grab any solution?
Anyone you want.
Okay.
Yep.
We'll do B.
50 milliliters, right?
Actually, we're gonna do A because I want an A.
Okay. There's a part at the top where you can write in the solution.
Yeah. So everyone write solution A in their thing. Okay, I'm gonna get 25. Or should I get? Yeah, I'll just. Okay, that's like exactly 20.
Yeah, I think you guys all just stayed there and you're like, this is fine. And Hudson was the only one that went the room through. That's funny. Okay.
It's like there's not a line for 25. It's like separately in the center.
So again, Olivia, probably just want to get 50 because you're going to do all
Oh, that's right.
with the graduate cylinder, right?
Wait, but
You always get skipped more than you need,
okay.
but then use the graduated cylinder when you're ready to take the actual volume.
Okay. That's smart.
Okay, so
Okay, that's a little more than 50.
the weight for the empty is 268.338 grams.
Okay. Okay. So I'm gonna weigh the graduated cylinder right now.
Sleeping with sirens, is that a band?
Mr. Jackson, this won't fit in.
Oh, yeah, sorry, this is like, thank you.
Should I get a small one? Or should I put it in the top?
This needs to be up here because if it falls over, then it won't break.
Okay.
And you don't have to put it through the top because you can just go like this.
Oh.
Right? Yep. Cool.
Does it matter which one we get?
Nope.
Okay, it's zeroed out.
No, you get 50 milliliters, but you have to choose how much you're going to use. You can only use 50 of that though. So you should probably pour it into a
Okay, for the mass of the graduated cylinder, I got 89.303 grams.
Well, still pour it into 100 milliliter.
For the what?
The mass of the graduated cylinder.
We don't pour directly on top of the graduated cylinder. You want to keep it.
Okay, it just went up to 89.307 grams. Okay, so now, just kidding, 89.306. It keeps changing. We're just gonna stay with that. Okay, so now I'm gonna do 25 milliliters of the NaCl solution. Okay.
We got the soap.
Does anyone remember if we measure at the bottom of the meniscus or the top?
I
We
think
measure
it's
at
like
the
the
bottom.
bottom.
We measure at the top for ones that go up like
Wait, sorry, the ring lab. What?
You measure, yeah, it's so loud. You measure from the bottom of the meniscus for everything except like iodine, I think,
Okay, thank
or
you.
mercury. It's one of those two. I don't know.
Okay, I would like need a tiny bit more.
No. Open the side.
Okay, that's good. Okay, so 25 milliliters. 25 milliliters of NaCl. Just write that down just in
You guys
case.
have very little experience. Most of the time you would have.
Okay, so now I'm gonna weigh this,
20 labs, like-
and then we're gonna find the mass of the NaCl.
Yeah, like, I mean, all of that. It's like taking children and taking them, you know, to like the most advanced toy park ever or something.
Yeah, it's great. Okay, so I'm gonna
Okay,
measure
so for the mass of the NaCl and the graduated cylinder, I got 114.814.
Ooh, can I get one that says A? Wait, no, which letter do I like?
Wait, can you repeat that?
Yeah. It changed again. The mass of the graduated cylinder and the NaCl is 114.818. I mean 815. 114.815.
So that means that the solution is like 25.509.
Okay.
So much cleaning, right?
Okay, I'm just gonna
This is where we want to check. You have a mass of it. Yes. Because then you have the mass of this, and you do the mass of this.
yeah, so I got the same 25.509.
That's right there, which will in the solution and put it in here. Here we go, stir it up. That's long enough. That's long enough.
Okay.
So what you're doing
So now
right now is kind of
we're gonna find the mass of the large empty beaker, which I think I'm gonna use this to heat it up. So I need to find the mass of that.
So you could have
Dry.
that into 60 or between 40 and 60 because you're going to actually do the measuring here, right?
Oh, yeah.
Yep.
I have 4 minutes.
You can't put anything back in your gear. Yep. Well, you're pouring it to whatever you think you need.
Okay, zeroed it back out. Mr. Jackson, we use this big guy, right?
Oh, no, I didn't know.
What's up?
We use this one to heat it up?
Yep, you have the mass of that empty?
No, that's what I'm taking. I just want to make sure I had the right one. Okay, now I'm taking the mass of this empty and dry.
So yeah, I don't know why this one doesn't let you see.
I know, it's weird. It's kind of lonely.
It's lonely.
Yeah.
You can pull yours out too if you want. Yep. So if you have the weight of this, then you pour the solution in there, you can get the mass of the solution. And that's important to find that by.
40 milliliters.
Oh, okay, we were just gonna pour it back into this.
Okay, so the mass of the empty, like, big beaker is 278.9 0.131 grams.
Be part of that. So you won't be able to get all of it out of here into there.
Can you say that again? Sorry.
Yeah, you're fine. 278.131 grams.
So you're gonna need to wait at the beaker later.
Never mind, don't get rid of the weight of the beaker, just, I'm gonna weigh this, yeah, great.
Okay, so now I'm gonna put the solution into the beaker and I have to wash it out with this thing. That's just what he said to do. I don't really understand it. I think it's to make sure all the NaCl gets out.
The weight of the graduated cylinder, is, sorry,
Okay.
so, okay, so the weight of the graduated cylinder is 89.749.
This is the part
That's
I like.
not, that's soap. That's not distilled water.
Oh,
Yeah,
that would have been bad.
that would have been bad.
Okay.
That's why it's got a little bit of color to it.
Okay, I was wondering that. Okay. So now I'm gonna wash this out with this. Do I just like go like that?
Yeah, tilt it and shoot it up like this. Point that, yep, there you go. Make sure that you're over it though.
It's not shooting out. I need more.
Here, give me that, I don't know.
Yeah.
So now I'm gonna pour the solution into the graduated
Uh-huh.
cylinder, and, yeah, so now, yeah, that is 100.
It's kind of hard.
So I should put 25 layers in it. And that's
Pour the solution into the graduated.
Okay. That's good. Okay, so now. Okay, so now we're gonna heat it up. This is what I have, and I'm gonna put it on like the heater.
Okay, cool. So we're at 25. So that's 25 milliliters of the.
Do I turn it to a certain knob? Or?
All the way up.
So now what we're gonna do is
Okay, so I turned it all the way up,
we're gonna wait,
and now we wait for it to evaporate.
right?
Probably want to get some goggles when you're doing it.
Okay. Turn it back.
Just in case.
Yeah. Okay, that's right. Cool. I'm gonna wait.
Now we play the waiting game when we set up all of our equations.
Okay.
Okay, so now he says, I have to wear goggles when I'm doing this, which is kind of annoying, but it's fine. Actually, so now he said to set up all of our equations while we're waiting for it to heat up.
So,
Okay, so
You got it in the big one?
hold on, I'll be right back.
You know the mass of it? You know the mass of it? Yeah. You're good. Yep. Rinse it out, yep. There we go.
I'm just getting the equations out. It's easier.
We have to write down our work on the page.
I think so, but honestly, you can do it on the back or something because there's not a lot of room.
Yeah.
What?
I think we gotta write down the work in the conclusion spot because that's where it gives us all like the things we're supposed to find.
I thought
Yeah,
the conclusion
okay.
was writing. Like it's like because it's a lab write out, right? We're supposed to be like, we found the blah 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 blah, you know?
I think that's the explanation.
Oh, I didn't see that. Okay, yeah, then I think we do the math in the conclusion.
So we need to find percent by mass first, which is mass of solute over mass of solute plus mass of solvent. Wait, we haven't.
We don't have the mass of that yet. We haven't.
Yeah.
Okay.
He told me to set up the equations, but we don't have the information, so it's fine. Ooh, it's evaporating. I don't know if you guys can see that, but it's like smoking out. It's kind of cool. So I'm just gonna wait until like most of it evaporates. I'll come back.
Do we have the mass of the solution? Isn't that what we found, or am I just getting confused?
Yeah, we have the mass of the solution, but we don't have the mass of the solute.
Okay. So I yeah, okay.
So is the solution just NaCl, and then the solute is the salt?
Yeah.
Those have salt.
Oh, okay, that makes sense.
They won't be in here, so we won't be able to count them. But if we rinse it,
Oh, I see, 'cause it's gonna evaporate anyway.
it's gonna evaporate anyway. We don't even care about it, right?
Oh, yeah.
That's it. You don't want to do. too
Mr.
much,
Jackson.
extend the time to get it.
Okay, cool.
Cool.
Okay, so.
Would I find the mass of the, like, would I subtract the mass of the solution from the mass of the solvent? I mean, the solute to find the mass of solvent?
Mass of the solution from the graduated cylinder minus the mass of the solute will give you the mass of the solvent.
Okay, yeah. So after, like, I find the mass of the solvent, basically we have to subtract that from the mass of the solution to find the mass of the solvent.
So as soon as you start to see that precipitate, did you guys show them? Did you show them how
Yeah.
this looks a little bit?
Yeah.
So as soon as you start to see that precipitate come, you're gonna, boom, turn it off.
Okay. But don't you want the bubbles around it, or you don't want the
Yeah,
water bubbles?
what we're hoping for is that if we need to add a little more heat, we can later.
Okay. So when should I
Basically,
turn
we
it
don't want it to pop out.
Okay.
Yep. And you definitely want to wear goggles because if you get that popped into your eye, you're gonna get.
It's like, it keeps fogging up whenever
I get you. I get you. I wear glasses every day. I know the fog up.
Whenever glasses with a mask, I put like a Band-Aid right here, so like.
Yeah.
That's hard.
I've got this piece of metal right here. Does it pretty well.
Wait, so when should I turn it down?
You guys see the.
As soon as you start to see the precipitate.
Okay. Hannah, don't try to do something wrong. All the way. Okay, I'll
Does anyone know what he means when he says the precipitate forming? Because
When you start to see like the salt.
okay.
You want to try what she said?
Yes.
You want a Band-Aid? You're good?
Okay, right now it's just bubbling. So
But
I don't know if you.
I don't think the Band-Aid has it.
Oh, man, that's just
I don't know if I have any cuts of Band-Aid.
like Spider-Man or something.
Yeah, right? Cool one. No. Oh, no.
Would the salt be like hardened? Would it be like a solid?
Yeah.
Okay.
What else did I draw here?
It will be a solid.
So when we're looking for molarity, we use the 25 milliliters for the bottom part for the liters of solution, right?
No, we would have to find the solvent, which so we would do the 25 grams minus whatever I get for the mass of the salt, and that's the solvent, and then we have to convert that to kilograms. Does that make sense?
Wait, so
Oh, molarity. You were talking about molarity. I'm sorry. I thought
oh
you said
yeah, for molarity
we would convert the 25.
to liters.
Yeah.
Okay, I just wanted to make sure that we use that number. Okay.
Wait, isn't it already in milliliters?
Yeah.
Oh, so we would do 25 milliliters. That's what I-
0.025 liters.
Yeah.
Who is that?
Margo.
Margot. I filled out this semester's Pride and Leadership Awards today. So you guys doing the labs both times awarded you a leadership award.
Oh, yeah.
Yeah.
Really talented. Oh, it's smoking.
gave Dawson a leadership award too.
Really?
What is leadership award?
Well, it's something that goes on, obviously, your academic career, but it also, okay, we're getting.
Oh, yeah.
Do we want
I see it.
Yep. Now we'll start
How far down?
all the way.
Oh, okay, so it started forming a solid, so we turned it all the way down. I don't know if they can see it or not.
Right.
But it's kind of cool. It's like crystal.
Yeah, right. That's the jumping we're talking about.
Yeah.
So you can see a little bit. Actually, let's try this. Let's take it off for a second.
Okay.
I don't know what Lady Gaga is. I just know.
And hopefully, the sides and stuff, we'll get it. Oh, that was a big chunk. Oh, we gotta take it off.
Okay.
Losing way too much. I'm not even sure if it's worth trying to get those two samples there and putting them back on.
Oh my god.
You might want to.
Really?
Yeah.
How would I just touch them?
Well, you could, but you might be better off trying to use a scapula or something, right? Maybe
My
that's
Computer just crashed. Did I miss any like new weights or anything?
No.
No, okay.
Oh, they can hear you? Why is they can hear me?
Not anymore. Okay.
Maybe with the Sterling.
I thought that song was after like 10 years.
I would use this part. I would use the last part. Yep.
That's weird, bro.
Oh, yep.
That's weird.
Yeah.
It looks weird.
What is it? Oh, careful. So you want to turn it off at this point?
Okay, so right now we're just waiting for like the stuff on the sides to go away. But that's what it looks like. It looks like kind of like paper or like peeled paint, actually.
Looks weird, yo.
And once like all those droplets on the side come down, then I can take the mass of it, and then we can start the work. Looks like that. Some of it, some of
We're
it
hoping
fell
that
out. Like,
later on when we heat it
Oh,
more,
it literally just
that'll
looks like
go away.
salt.
Yeah, it looks
If
like.
it doesn't,
Look at this. Looks like peeled paint.
Yeah, yeah.
yeah. So we're
What do-
hoping
wait,
that
what do
it's
you- what do
gonna
we
go
do
away
after
when
that?
we heat it more.
We take the
Right now, we
mass
just
of
don't
all
want
that
it to
together,
pop
and then we
because
subtract it from the mass of
We
that
lose
beaker.
the salt. Then we get that popping.
And then you just put in the mass of the solvent.
Right.
It's a lot of work. I know. Yeah, take it slow.
Can you just pick that up? Isn't it hot?
Not up here.
Oh,
That's
okay.
another reason we're using these large ones. So if it starts to pop,
Almost
grab it
done.
off there. So just, fill it.
Kind of a lot of weight.
Yeah, if it's sizzling and you don't want it to pop, so you want to get it off as soon as you hear sizzling.
Like now?
No, or
If it's sizzling, I think.
as long as it's not popping, you're good, but if it's sizzling, it might be ready to pop. So
Just so we have it for like later, when we start solving stuff, the molar mass of NaCl is 58.44.
Okay.
I'm
gonna write that down.
happens with this math, right? Don't want that now.
No, it's Jesus.
What?
Did you say 58.4?
Let's see.
58.44.
Okay.
Yeah. I guess when you're going like this, right? It's not
I think
the
we should,
mass,
once I get the mass of this, I think we should find the solvent.
It's not the easiest,
So we get a
right?
percent by mass.
So we do need to heat this a little more, it looks like, to get that right there. Has it been popping much or anything?
No.
No. All right, so right there, we're gonna account for air. Hopefully it's not too much, right?
Okay.
After you make your measurements.
It's still bubbling, so it's just.
When we're doing like percent error, if in like in our explanation, if we want to say, because we're putting it back on the stove right now or whatever it's called, because there were still droplets around it, so we need to make those go away. We could say that, like that could contribute to our percent error because we had to add more heat than needed.
Okay, you want to learn some choreography? So, get out. 1, 2, 3, 4.
Are you letting them listen to you or did you do that?
Wait, how would we do percent? What's percent error again?
I don't know. I'm gonna ask him at the end.
Okay. Because are we calculating to find what it should be? And then, oh yeah, we calculate to find what it should be and then versus what we got, right?
Yep, and I can tell you what it should be right now.
Oh, okay. I was like, we're gonna have to do this all.
Yeah, that's why I was confused.
Don't put it back on if it's like that.
We can clarify this later, but I'm pretty sure percent error is the accepted minus the experimental, and then that is all divided by the accepted value.
That sounds right. And then times 100.
Yeah,
Mine is at
I think so.
That sounds right. But I think we can ask.
Yeah, we
We
should.
start with it off,
I'll ask later.
or you can just barely on or whatever, but you can set it on there for a few seconds and then pull it back off. Basically, we need to get rid of all the moisture here and here. So we don't want it to pop. You want to be careful looking over it, some of it to pop up in your face.
This looks good.
Looks good?
Yeah, I think so.
All right, what about that? What about that? What about that?
They blended it.
They blended in, you were looking at it from up here, so you didn't, yeah, right? When you go down here, you can start to see them. So, I mean, I'm not thinking that's gonna be more than
and
3
it's
minutes.
something, something's in around it.
What's I doing, getting concentration?
Or the theoretical. I don't know.
Yep. All right, A was 0.50 molar. B, you can write this down, B. Thank you.
0.50 more.
No, that was A. You weren't A, were you?
Yeah.
You were A?
Wait, no, second, I lied.
You were B, right?
Okay, so for
Talking about?
B.
what?
What is he talking about?
Okay, so I just got the theoretical for our percent mass,
B was
and it's
0.50
0.50 molar.
And D was 1.25. molar.
Wait, 0.57?
0.50.
The correct answer is 1.
And do we have the weight for the the full beaker yet?
Yeah.
Oh, what is it? I missed that.
The mass of the empty beaker is 278.131
What's the 1.25?
grams.
Mm-hmm. Have you gotten the mass of it like with the salt in it yet? No? Okay.
Waiting for all the droplets to dry out
So this will be.
because it'll add to the mass, and we don't want that there. So it's on the stove right now. I'm waiting for Mr. Jackson to give me this.
Does the 0.50 molar go both on top and bottom, and then you subtract what we got at the bottom?
I don't know the correct formula. I always mix it up. I'll ask Mr. Jackson.
1.25 is theoretical.
Wait, okay, so we're supposed to write the 0.50 molar under or on the percent by mass? Are we ready?
Yeah.
The theoretical, like.
No, on the percent error. Don't. It's not the correct answer yet.
Don't start any calculations yet because we don't have the solute.
Yeah.
So you write 0.50 on the percent error one?
No,
Yeah.
don't write anything yet.
Okay.
You can write it. It's just for reference.
Yeah, but that's not the answer. It's just what it should be. Like we still have to do all the calculations.
Yeah.
Mr. Jackson, is
Yeah.
this like good? I'm not forgetting
Well,
it all.
Yeah, right, that moisture right there will be out of the mass, so we can't have it. So we might want to start turning it up again.
That's the theory.
Okay, it's definitely done.
So now we're just waiting for, oops, sorry. We're
Every
just
time
waiting
someone
for.
asked me what I was on, and I said.
I want it all
it's the prefix for
What
one.
were you on?
Someone asked, what are you on? And I said, it's the prefix for one.
Uno, what is it? Mono? What?
Meth.
Meth.
I
So
said,
now we're going to let this cool because it's too hot to sit on that.
Okay.
But yeah, it looks good to me. I'm gonna sit it right there.
All right.
Oh, I'm not gonna sit it right there because it's so hot, it's gonna burn that, right? We'll sit it on the table.
Okay, so now we're letting it cool because it's too hot to put on the scale. It actually just hold on. It like burned the napkins when you put it on there.
Yeah, so that would do a number on the metal on that scale. Right?
Yeah.
If it's that hot and you cool it too quickly, that could actually cause the crystal to crack, and then your experiment's done. Do you let them talk to each other? Do they talk to each other, or they just wait for you? No, that is not allowed. They don't talk to each other. No. I don't think your group's a fun group right now. Just saying, we're not.
No, I'm the only one who just talking.
And then it plays occasionally every time. Yeah. Who else is in there? Is it just those four? We don't even know about. I've been friends from never seen.
They could be dead.
We would never know.
We would never know. Yeah. Oh, really?
I would say about 3 more minutes, maybe. If you look back here, we have a little bit of moisture. But in 3 minutes or so, that should be good. Are we still burning napkins over here?
I have no idea.
About 3 more minutes and it will be 50.
We're no longer burning napkins. It's still too hot.
Okay.
If you can't put your hand on it for more than, and I mean, always start up top.
Yeah.
More than a second, then you should be able to actually hold on to it for like 10 or 11 seconds before you put it on there.
Okay. We're still waiting for it to cool. And we might not finish all the calculations in class, but it's just like the work we did in the packet. I don't think it's a big deal.
Or you could say, what's the other one? I like that word from the regular show.
From the what? So,
The regular show is like a cartoon. Wait, I'll show you a picture of the video.
Do you hear about the things? What bugs? They're gonna come out of the earth?
cicadas.
Oh.
Yeah.
When I was a kid. Yeah. Well, let's leave that there.
Yeah.
When I was a kid, probably younger than you guys, like 10 years old, it was like the biggest cicada thing in the world. I lived out in the country, and we could catch them and fill up garbage bags.
That is
big.
disgusting.
Yeah.
I hate that.
Like my cats, at the time I had like, I lived on a kind of a farm land, and
No.
I had like 10 cats, and they would just be like jumping and getting them out of the air.
Oh, no.
And it was eating the heck out of them. It was crazy.
I hate cats and they're outdoor cats and they're gonna bring them in.
Oh, yeah.
Oh,
It's like literally it was the worst thing ever. Like, I mean, filling up a garbage bag in a day was not, it was easy.
Mr. Jackson,
Yeah.
it's happening this.
what's the correct formula for percent error again?
The absolute value of the actual or experimental minus or theoretical minus experimental divided by theoretical. In this case, the theoretical is based on me making the solution.
Okay.
And that's that number I gave you.
Yeah. Okay.
Yep.
Mr. Jackson, I think this is good.
You're supposed to good. Getting more water droplets?
Okay. So the formula for percent error is like absolute value theoretical minus experimental over theoretical times 100. And the theoretical was the 0.5 molar he gave us.
Wait, can you repeat that one more time?
Yeah. The percent error
So we got them so hard you
equation
can see.
is absolute value theoretical minus experimental over theoretical times 100. And the theoretical was the 0.5 molar he gave us. And we're going to find the experimental, basically.
Before you guys do put it on the scale, make sure you wipe the bottom of it because it could pick up things from the table Like, you know what I mean? Like something you can stick to it from the table, which will add mass. So a picture of you lighting your food will put milk on fire.
Almost there. Sorry, guys. It's taking me forever.
Okay, so it's done, everything's going, you just have to wait for it to cool off so you can put it in the scale.
Set up your formula. Ryan, Mike, how all your formula set up for you?
I have the formula set up for molarity. So it's like X or like whatever we find over 0.25 liters times 58.44 grams and then 1 mole on top of it.
Okay, so let me write that down. So
Yeah.
X over, did you say 0.25
Yeah, 0.25 liters.
liters times 1 mole?
It'd be 0.025.
Oh, it would?
Yeah, I think so.
Oh, yeah. And would it be 0.025509? Because that was like,
No, because we're gonna use the milliliters.
oh, that's right. I keep mixing those up. Okay.
Wait, and what formula is that for? Molarity or the?
Yeah, it's for molarity.
Okay.
Thank you, Raylan.
Yeah, and then for molality, we just take our answer from molarity, and then we take the solvent and change it to kilograms and then put it over each other.
This is good.
Okay. 1 second.
Ready?
All right, we're ready. Okay, I'm weighing this now, and then we'll find the.
That's the flipping flyer. Spin it. Yep.
Alrighty. So the mass.
Like spin it like a frisbee.
Hold on, I'm writing it down.
Yep.
The mass of the empty beaker and the salt is 278.804 grams.
Like real quick. Yeah. Yeah. And the idea is to keep it spinning.
So this is the mass of the beaker and the sodium.
Yes.
Sodium chloride.
Sodium chloride. You're correct.
What have we been? Wait, I'm sorry.
That means that the solute is like 0.673 grams.
Wait, what?
Like while I'm weighing it, you guys want to try to like figure out the
Yeah, it's tiny. It's like
Wait, what was the number again?
it's
0.673.
No, the whole thing.
Oh,
278.810. Sorry, it's
Wait. When we did the mass of the NaCl earlier, was that the NaCl salt solution?
yes.
Okay, so
So now we're gonna subtract the mass of the NaCl from the mass of the salt to find the solvent. So solution minus solute equals solvent. But
is it 804 or 810?
810. Sorry, it changed on me.
Okay, so that means the solute is 0.679.
Wait, sorry. Now it's 814. I'm sorry.
Oh, okay.
Long. And remember,
Oh,
it's cooling down.
Okay.
So you might as well just take the measurement and be done with it.
Okay. So I'm just gonna stick with 278.810. That's like the final one.
is 269.381.
Task number 15.
Where do you live now? House number 12? What?
Okay, so I got 0.679, same as Raylan.
And then that makes the solvent 24.83 grams.
Okay.
Wait, you said the solvent is 24.83 grams, right?
Yeah.
Probably like the bottom of that 100.
Wait, say that again, Raylan.
Oh, the solvent is 24.83.
Okay. Okay. All right, so now we're gonna do molarity. So that means,
Wait, should we do the percent mass first?
yeah, I was just going with molarity because Raylan said that, but yeah.
So it would be the mass of the solute, which is the NaCl, over the whole thing, so 25.509.
Yeah.
Okay.
So it'd be 0.679 over 25.509. That's what I got.
Then times 100.
Yes.
And I think it's 3 sig figs, right?
Yeah.
So I got 2.66.
Yeah, same.
Graduated cylinder weighs.
Beaker.
The beaker.
And that doesn't have a unit, right?
Yeah.
Would you put the percent side?
Yeah, but it's already there, so.
Oh, yeah.
Okay, so molarity would be 0.679 over 0.025 liters times 1 mole over 58.44 grams. Does anyone else?
Are
That's
you
right.
doing molality or molarity?
Molarity.
Okay.
Yeah, and then the final answer for that is 0.46 because it's 2 sig figs.
Wait, I
is
haven't.
5.
Wait, did you guys find the moles yet?
We're finding the moles through molarity.
Yeah,
Oh, okay.
because we divided by the molar mass. And it's 2 sig figs, so 0.46, right?
Yeah.
Okay.
Percent air.
Okay, so now molality,
Percent air goes.
mole solute, so
And why it may be off.
0.679 divided by 58.44. Okay. So for mole solute, I got like 0.0116187, all that stuff. For molality, like on the top.
Wait, I thought on the top would just be the 0.46.
No, because that's like divided by the liters. You just want the moles of the solute.
Oh, okay.
It's like a long decimal. So I would encourage you to do it in your calculator.
I did that and I got 0.024577.
Okay, so and then the solvent is 24.83 grams. Isn't there 1,000 grams in 1 kilogram, right?
Yeah.
Okay, so we would do 24.83 divided by 1,000, and that would give us the grams of solvent.
Yeah, it's like 0.02483.
Okay, thanks, Raylan.
Yeah.
Okay, so I got 0.47. Wait, how many sig figs would we round to?
It'll be 3, I think, right? 3 or
Yeah.
4.
What was the milliliters based on? If you based on whatever milliliters.
Where did you get 3 from?
Yeah.
Never mind. It should be 4 because of the 2483
Yeah,
kilograms.
that's what I was thinking.
Okay. So it would be 0.4679.
Yeah.
Okay.
Wait, 0.4679.
Yes.
And then what unit is there?
Lowercase m.
Okay.
Molarity is uppercase m. Molality is lowercase m. Okay, so we found all that, and then we just needed to find, like, the objective was just to find the molarity. So now I think that's how we use the percent error. And we're actually kind of close. We're only like 0.04 off of what he got.
The number of liters was 25 milliliters. So then you convert that to liters and you get 0.02.
25.0 roughly.
Okay, so the equation I got for that is in absolute value 0.5 mole minus 0.46 mole divided by 0.5 mole times 100.
I have a question. Wait, what did we get from molality and molarity? Because I did it, but I don't.
Okay, so for molality, we got 0.4679,
Okay.
and then for molarity, we got 0.46.
Okay. Wait, 0.4679.
For molality, yeah.
Where did you? Okay, I think I did it wrong. I got 0.4672. I think I rounded it too.
Okay.
Wait, I've got a quick question.
Yeah.
For percent error, you said, can you repeat the equation? Because I'm pretty
Yeah.
sure I had something else.
So yeah, so Mr. Jackson gave us the theoretical, which is 0.5. So I did in absolute value 0.5 mole minus 0.46 mole divided by 0.5 mole times 100.
Oh yeah, that's what I had to.
Okay.
So the first one was 0.01.
What did you get?
I'm doing it right now.
I got 8%.
That's what I got to. 8.
Same.
Okay, same.
What did you find to be the molarity?
Huh?
What'd you find to be the molarity?
0.46.
All right, so pretty close, right?
Yeah.
Good.
Okay. Awesome.
We can explain that too, probably.
Because I kept it on.
So for the explanation, what do we got to put down? Like why our percent error is the way it is, or like what we did in total? Because what we did in total was the procedures, right?
Yeah. So we would explain why our percent error is the way it is. And for
Okay.
one of that, we could do, he told me to do like the droplets were still on here for a while. So we put it back on the stove to heat it up again to make the droplets go away. And that's probably why our percent error was a little off.
Probably why it's the popping of the salt.
Oh, okay. That too? Or,
That's probably the main reason.
oh, okay. And the main reason is the popping of the
Right
salt.
here, right here.
Oh, okay. Just kidding. Scratch everything I said. Just kidding. So why our percent error could be off is because the salt kept popping out of the beaker. And at one point I even had to put the salt back in the beaker, like the big flakes. So yeah, that would be the main reason.
That's how you explain a lower than what it should be.
Okay.
If it were higher than it should be, then you would look for droplets.
Oh,
So
okay.
that's what,
Okay.
yeah. Right?
Okay, that makes sense. Did everyone hear that?
I got it.
Okay.
Yeah, I got it too.
Okay.
Hey guys, 3 minutes.
And once you get that, you can leave because we have 3 minutes left in this class.
Okay, thank you, Olivia.
Bye. Thank you.
That's what I got.
Okay, cool. So now what do we go?
That's
Have a good weekend, Olivia.
Yes, I am actually.
So then we just write that on there.
I'm excited.